Hello there, I am Dr. C.N. Okolugbo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis for business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. Hello everyone, thank you for joining me on this channel once again. And thank you for following me through on this series on differential calculus. What we've been going through over time has been looking at rules of difference, rules on derivatives, finding derivatives of the y function. And remember, we have gone through what we call the constant rule. We've gone through the linear function rule. We've gone through the power function rule. We've gone through the sum difference rule. We've also gone through the product rule, where we have to find the derivative of the product of two functions. Then we have also looked at the quotient rule. Today we are going to look at a new rule or another rule in derivatives, and that's what we call the chain rule. I said it is called the chain rule. What we mean by chain rule is where you have a function that has a power. How do you deal with that? Where you have a function that is raised to power of something, because all the while we've all just been looking at solving questions that have to do with just a function that has two components. But now you are now having a function that they are all squared or all cubed or raised to power 10 or 7 or something. So how do you solve such kind of problem? That's what we call the chain rule, or we'll call it the composite function, where you have a function. Look at what we have on the board. Let's look at an example. When we talk about chain rule, we're talking about having what we call composite function. An example of that is where you have y is equal to 4x plus 1 raised to 4x plus 1 raised to power 2, or raised to power 5, or raised to power 10, whatever it is. How do you deal with this? To solve this problem, because you have these two, if they were separated, you would have done them, you would have just found the derivative of of each of them. But in this case, they are all locked up in this. That's what we mean by composite function. So in dealing with composite function, we have a scenario of y is equal to f of x all squared raised to some kind of power. What we do in this case is that we represent this function by u, so that it becomes y is equal to u raised to power n. That's what we do. Then, knowing that u is also f of x, so u is also f of x. So y, well, we have the function in here just like this. This is the function in here, raised to power n. And then we are representing, let's say, let f of x be what? Be u. And that's what we have done here. Let f of x be u. So u is now in here, represented by this, and u is this. So in order to find the derivative dy dx of the main function is to find dy du times du dx. Hey, I hope I'm not confusing you here. Now what we do is that we find the function of this one, we find the derivative derivative, this is dy du. This is u in here. Well, find the derivative of y based on u. That's why it is dy du. And then we are finding the derivative of u. That's why it is du dx. That is, find the derivative of u based on u. Find the derivative of y based on u. That's dy du. And find the derivative of u based on x. That's why it is du dx. Do you now understand? Do you now understand? Okay, I'll go over it again. What we'll do is that to find the derivative of the main function y, we will represent the function in here by u. And then the u itself is a function. So to find the derivative of it, we will now differentiate this. We'll differentiate y by having dy du based on u, and then we're also now going to differentiate u by having du dx. When we've done that, we now multiply dy du, whatever we get as dy du, multiply by du dx. And when we do that, we will now, after we've found that, we will return the value, what we represent as u, back to the function again, back to the equation that we have. Let's look at an example that we have. So let's look up here, example 1. Example 1 of the chain rule. And I have an interesting question here. I say y is equal to 1 plus x raised to power 2 or raised to power 10. Now, how do you solve this? Do you just have, since you know differential calculus, do you just say 10, you put 10 here, and minus 1 will mean 9, and that's the answer? No, that's not the case. So let's represent whatever is in here by u. So let the composite function be u, so that we can rewrite this as y is equal to u raised to the power 10. Can you see that? So instead of having this, it's u raised to the power 10, and we know that u is equal to 1 plus x raised to power x raised to power 2. Okay, so now we need to differentiate both of them. So dy du based on u is going to be 10 u raised to power 9. 10 times 1, that gives us 10. 10 minus 1 gives us 9. Okay, and then du dx is going to be what? When we differentiate this, the 1 will go, and then we're left with 2x. 2 will come here, becomes 2. 2 minus 1 gives us 1, so that gives us 2x. So to find the derivative of the main function dy dx will be just as we have, that is dy du times du dx, and that will be dy du. I've already got it as 10 u raised to the power 9 times, what do we have, times 2x. So we already have this raised to the power 9 times 2x. What we now do is that we now write out what u is. So this becomes, we'll go back to what u is. So this becomes 10 times 1 plus x raised to the power 2, close the bracket, 9 times 2x. And since we already have 2x on this side, let's multiply 2x by 10. This becomes 20x into 1 plus 10, 1 plus x raised to the power 2, raised to the power 2 raised to the power 9. So this is our answer. This is the answer to this question of finding this is what we call the chain rule. This is finding the derivative of this function. Please watch out for more videos on chain rule. We'll treat more examples to buttress and to establish our knowledge in this rule of differential calculus. Thank you very much.